Welcome to Study Loop.
So this question is going to address the topic of like percent composition for a given species, and we're asked to determine the percentage of, not the percentage, but the actual mass of sodium in a series of examples. And so the first example deals with sodium chloride. And so we sort of want to start the process by determining the overall molar mass or formula weight of sodium chloride. And so we can see that it contains one sodium atom, one chlorine atom, and utilize the periodic table here to indicate to us that chlorine has a molar mass of 35.5 grams per mole, sodium 23.0 grams per mole. So the overall formula mass, if we add those two together, is 58.5 grams per mole, um, molar mass or formula mass for sodium chloride. Now, of that 58.5 grams, 23 of the grams is sodium. So let's express that as a percentage. 23 divided by 58.5 gives us a ratio of 0.393. Or if we were to write that as a percentage, we would say then that 39.3% of the mass of sodium chloride consists of sodium. Now, what they tell us is we have an 8.5 gram sample. And if we multiply that then by this percentage or by this ratio, this should tell us how many of those 8.5 grams consists of just sodium. And if we crunch the numbers out here and multiply by that fraction or percentage of sodium, we determine that 3.3 grams of that 8.5 gram sample do indeed consist of sodium, and report that to two significant figures as expressed in the data provided. Let's try another example. So in the next example, we have sodium phosphate. This is another food additive, they tell us. And they're essentially saying that, again, the process is similar. What percent composition does sodium make up in sodium phosphate? Or how many grams of sodium do we have in sodium phosphate? So again, we look at what's the molar or formula mass. Well, in this example, we have three atoms or moles of phosphate. And so we take that molar mass for phosphate, 23 grams, and multiply it by 3 to accommodate for all three sodium atoms. Oxygen, we notice in the phosphate, there are 4 oxygen atoms. Oxygen's molar mass is 16, so we need to multiply that by 4. And finally, the one phosphorus atom has a molar mass of about 31 grams per mole, so we'll add that in as well. And if we add up all of the numbers, we end up getting a total molar or formula mass for sodium phosphate as 164 grams per mole. Now, out of that 164 grams, 69 grams is sodium. Okay, remember we have 3 sodiums to account for. 3 times 23 gives us 69. So let's calculate that as a percentage or as a fraction and see what we get. So we end up getting a fraction of 0.421, or about 42% is sodium. Again, we have an 8.5 gram sample size multiplied by the fraction of sodium in that sample, and we end up getting 3.6 grams of sodium then that are present in the sodium phosphate sample. So very similar to what we saw with sodium chloride. Let's try a couple of other examples here. So the next example uses another food additive, sodium benzoate. So the benzoate structure is kind of complex, but we can see it consists of some carbon, hydrogen, and oxygen. Once again, let's find the molar mass of the sodium benzoate. So just one sodium atom involved here, 7 carbons, each with a molar mass of 12 grams per mole, 5 hydrogens, 1 gram per mole, and 2 oxygens at 16 grams per mole. And if we add all the numbers up, we end up getting a molar mass of 144.1 for sodium benzoate. So we notice here that out of that quantity, 23 grams is represented by the sodium. Let's go ahead and figure that out as a fraction as we've been doing. And that fraction ends up being about 16% or 0.160 as a fraction of sodium in the sodium benzoate. Let's multiply that by the 8.5 gram sample size, and we end up getting about 1.4 grams of sodium this time, much less than the other examples, that we'd expect to be present in that sodium benzoate example. The final example uses sodium hydrogen citrate. And so another sort of complex example. So we add up, in this case, 2 sodiums plus 6 carbons, 6 hydrogens, and 7 oxygens. And if we add those up, we end up getting a molar mass for the sodium hydrogen citrate at 236.1 grams per mole. And again, from the formula, 2 sodiums are going to be present. So 2 times 23, 46 grams out of the 236.1 total grams will be with respect to sodium here. Let's figure that out as a fraction again. And so taking that division or dividing that problem out, we get a fraction of 0.195. And multiply that again by our 8.5 gram sample size. And overall, we end up getting 1.7 grams, check my numbers there, sodium present in that 8.5 gram sample based on those numbers.